Hey, Libby, we are starting. Number two. This is number 2. They want us to find all the things. The VAs, the HAs, the maxes, mins, POIs, which means...
Wait, do you have a...
She's taking her final.
Oh.
Yeah, she's here. She's taking, yeah. So this is my first derivative and this is my second derivative. And it's going to be a little bit ugly, but, you know, we'll manage. It'll be all right. Okay, so here we go. The HAs. Let's do the HA first. Okay, HA, we look at N and M. What's N?
The numerator.
The numerator. What's the numerator?
None.
0. M is
2.
2. He is bottom heavy, so he is sitting at y equals 0. That's his HA. Okay, so I'm gonna draw him over here. We have to sketch him.
You have to draw him?
I don't know, but I'm just gonna do a rough sketch. You don't have to draw him if you don't want to. I'm gonna draw him. Y equals 0. That's what y equals 0 is. Okay. Next, the VA. Set the denominator equal to 0. So x squared minus 4 equals 0. Can you guys do that in your head?
2.
Add the 4, take the square root, x equals plus minus 2. So we have 2 VAs. Cool. 1, 2, 1, 2 VAs. Right there. Plus minus 2. There he is.
Is it 4,
Okay.
3? Okay.
All right. Now we have to do our first derivative. Okay.
X-intercepts.
How do we do first derivative?
You don't.
Do we have to do x-intercepts? I don't think we
We
do.
have to do x-intercepts for part A.
We do for part A
Yeah.
on number 2.
You're just not.
Oh.
You're just not.
Yeah.
It might help us to graph it though.
Do we-
X-intercepts,
Here, I'll
there
just tell you
are
what they are.
none. X-intercepts, there are none. On this one. Number
X
2.
minus 2.
What?
Oh, yeah, you're... What?
To do x-intercepts, I plug 0 in for y, right?
0.
The bottom multiplies over, so I have no
I
x-intercepts.
did the wrong one.
Yeah?
You have the wrong problem.
I do not either.
Yeah, you do.
What you talking about?
It's x squared minus 4 on the top and over 8x over 8x. X.
She
X.
doesn't even know.
8/3. That's what it is.
This is a rough day.
Oh gosh.
We're eating our parents and
X squared minus 4 over
Celebrating effort.
x to the 8/3 power.
Oh, darling.
What?
Those are the quick check exercises, the real number 2.
Why'd you say 201 was our thingy?
I'm sorry.
yeah, that one's on you because we
I'm sorry. Just leave it. Just leave it. Just leave it. Don't write this one down. Just leave it.
No, I don't have it done, so.
No x-intercepts. The y-intercept, plug 0 in for x. Can you do it?
We're just gonna restart.
No.
Plug 0 in for x real quick. What do you get?
I can't.
-4.
-2.
Negative 2.
-2. Crap.
Yeah? Right? 8 over -4, so -2.
Wow.
So
that is
he's
sad.
touching at -2
Okay.
right here. There's my dot. Cool.
But when I started.
Okay.
You didn't say
Now
square.
we didn't have to do that actually. What?
It's 0. It doesn't do
It
anything.
doesn't change if you saw the square or not. What was I doing? I didn't mean the top. Okay, leave me alone.
Okay.
I was just doing the bottom.
All right. Derivatives. Let's do the first derivative.
Okay, wait.
How do we do the first derivative?
behind
This guy.
The first derivative?
Yes.
Oh,
I don't
me
want
too.
Quotient
I did
rule.
not
Okay.
Either.
F prime G minus G prime F all over G
You
squared.
say that.
Okay.
So funny. Okay.
G squared is this guy squared. Okay. What's F? What's F prime?
0.
0 times G. We don't care what it is because it's all gonna go away. Minus G prime.
2x.
2x times F is
8.
8.
okay. So our first derivative, hey, that's real nice. Our first derivative is -16x all over that junk squared. Now what do we do with that?
Plug it in.
Don't get in.
Equals 0.
Equal to 0. Okay.
-16x 0.
The bottom's gonna go away, right? So -16x equals 0, and then divide by 16, so x is
0.
0. Cool. So we have that as a critical number. So I'm gonna
So
list
first
here. I'm gonna
derivative.
do this. I'm gonna do a list of critical numbers.
16x.
Okay.
over-
I have a critical number at 0. What else do I have for critical numbers?
0.
I actually have
2 and 4. Or
-2.
negative 2
Positive
and 2.
2.
-2 and 2 because these are
Vase.
VAs. Okay, so this is from the first derivative. So I'm gonna label those. Critical numbers from the first derivative are 0. VAs are -2 and 2. Cool. Now I have to do my second derivative. And I'm gonna add to my critical number list and I'm gonna do a whole big fat table and then like figure out my stuff, okay? So this guy we need to do the derivative of that.
No.
No, thank you.
Okay, here we go. F prime
What's
G
negative 16
minus
on the
G
top?
prime F all over G squared. Okay, so
Can we
G
just
squared
make it all-
will be X squared minus 4 to the 4th power, right? That squared squared? Okay. Alright, F prime, what's the derivative of F? Just negative 16 times that other junk. X squared minus 4 squared.
Wait.
I almost kind of want to square that out.
That was funny.
Can we do that? X squared minus 4 squared, do you know what that is?
X squared plus 4x
X to the 4th minus
16.
no,
minus
Yeah.
4.
minus 8x squared
Shoot.
plus 16.
Dang it.
Yeah?
Numbers from.
Why'd you do that?
X squared minus 4 squared is X squared minus 4 times X squared minus 4. Yeah? That's what he is, and that's what he becomes. So minus, now we can do G squared, and we don't have to do the chain rule, now we can just do the power rule, right? Okay, so what's the derivative of G, if that's what G is?
No.
4x
I
cubed
don't want to.
Minus 16x.
minus 16x, and that's it. Times F,
Drink more caffeine.
which is negative 16x. Okay,
I'm so tired.
okay. There's my second derivative.
I can tell. You're like, this is how you're looking at me. Guys, I stayed up
Okie doke.
until 11:30 last night.
Her mouth is open, her eyes
Okay, let's simplify him.
That's awesome.
Good thing we don't have a game today.
X squared minus 4 to the 4th, he stays on the bottom. Let's simplify the top. So, this guy, ugh,
16x to the 4th.
okay?
Plus whatever that is, x squared. Plus
Can you do 16? Can you do 16 times 8 in your head?
No.
Yes, you can.
No, I
42.
can't.
80 plus 48.
48. Crap.
80 plus 48. 128.
128.
Yay.
128.
How
X
did you
squared.
even do that, Coney? How'd you get that?
8 times 10 is 80. 8 times 6 is 48. 10 and 48. Or 80 and 48. True. That's a good thought. Yeah, that's another good thought. Okay. 16 times 16, you know what that is?
Nope.
No.
Minus 256. Okay.
Yeah, I did.
Now, I'm going to do this. This is negative right here, right? But I'm going to do this. I'm going to change him, and I'm going to make this plus at the back, and now back distribute him. Do you see that? You see what I just did? Okay.
64.
So plus
Fourth.
64x to the 4th
Minus
minus,
Whatever.
256 x squared.
you betcha. Okay. All right, let's put stuff together here now. All right, I have,
So good.
whoop, I have negative 16 and plus 64.
48.
48. You betcha. 48x to the 4th. Okay, done, done.
Sure, that is not.
Now this and this. What's 128 minus 256?
Negative
128.
128
Negative 128, x squared.
x squared.
Gone,
Minus
gone.
256.
Minus 256. Okay, now what is this? What is this right here?
More caffeine.
What is that?
That's the second derivative.
That's the second derivative. Set them equal to 0. The bottom drops out. What should we do at the top?
48.
Can we take out 48?
Yep, you can.
Can we really?
I don't actually know.
She's making me so loud.
Yeah, you can. Here, let me just try.
No, I don't think you can.
What?
256.
You can take out
so stupid.
16 though.
You can't take 48 out.
You can?
You can't.
Okay.
Why not, Haley?
No.
Because it comes up to 5.3 repeat.
I think you can take 16 out though.
Did you do
At the top.
Yeah.
Can you take 6?
X.
So
Oh,
3x
take
to
it
the
off it.
4th
What the heck is this?
minus
8.
8 x squared
Uh-huh.
minus 16.
Because we multiplied that together earlier. Ha.
Yeah, didn't we?
What are you talking
Ah, guess what? It's gonna
No.
work.
No,
Okay.
it's not.
All right, here we go. 16. Since we have him set equal to 0, we can just get rid of the 16 by like dividing the 16 off. So he's gone now. So this is what we have now.
I am
3.
not a repeat of yesterday in civics.
3x to the 4th minus 8x squared minus 16.
Add the 16.
No, we can't do that.
I know.
Even Robin was like,
She was like
She was
debating
like,
whether she
what
wanted
is
to
This is like quadratic form, right? X to the 4th x squared. Let's complex trinomial.
I know what that
Can we do that?
16 with 8.
3 times 16
48.
is negative 48. I want to add to get negative 8.
12 and 4.
Negative 12, positive 4.
Yep.
Yeah.
Okay. 3x to the 4th minus 12x squared plus 4x squared minus 16. And it's gonna work.
Is it?
You betcha.
Well, I can't do
It
it
is,
by
it is.
myself, and I don't want to do it by myself, so.
It
We've
is,
only
it is.
done one problem.
Well, what is that? Oh.
We're not even done with this. What are you talking about?
We're not even like started.
We're not even
So,
giving gloves.
we're doing a complex trinomial to the top. We took out a 16 and we threw them in the trash can, and now we're breaking this down. What shall we pull out of the first piece? 3. X squared. Okay, leftover is?
We can't.
We
don't
can't
know.
That was like harmonized. Did you see that?
Why does it do that? I don't know why.
We're hitting different
Okay.
notes. Yeah.
Okay, there you go. 3x squared. Leftover is x.
Wait, where are we at?
X
to
to
the
the
squared.
second.
X squared.
Can't see.
What?
X
Keep
squared
cutting out.
minus 4.
X minus 4.
Yeah.
Oh, x squared minus 4.
Yeah.
Oh. Oh.
That's
Yeah.
zero.
Yes. Take out.
You're
It
telling
is.
me we did that for no reason.
Then
though.
take out
2.
four.
Just to
Two.
Take out a 4. And left
4.
is?
Just kidding. X squared minus 4. No way.
No way.
No way, Jose.
No.
So my two.
way.
Okay. All right. So my two bubbles are
3x squared plus
3x
4.
3x squared plus 4 and
X squared minus 4.
x squared minus 4. Okay. If I set, this is gonna be kind of nice actually. If I set 3x squared minus 4 equal to 0, x squared equals negative 4/3. True? If I subtract 4 divided by 3,
Yeah.
then we take the square root, and that is
Oh my gosh,
I
the
don't
other one is
know.
our
Nothing.
boss.
because it's imaginary,
It's
so we don't care,
negative.
right? We don't have critical numbers that come from the first bubble, which is
We
good
don't have any.
because we have less critical numbers. Now, what's our critical numbers from here?
0, negative 2, and 2. Yeah.
Plus minus 2,
Plus minus 2. What are you
which
talking about?
means
Oh, yeah.
we only have 3 critical numbers. That's so exciting.
Wait, so we did all that for nothing?
No, because we still have to have the second derivative to plug in numbers to see what our
Got it,
concavity is.
Okay, yeah, that's.
So we set them equal to 0 kind of for nothing, but
yeah,
you know,
but
whatever.
like,
Anyway,
oh,
so
yeah.
we only have 3 critical numbers. That's terribly exciting. All right, here we go. Here's my table. Put your table somewhere.
I don't understand how it's a vol and it's a critical number. It's POI. What?
Probably. Yeah, I'm gonna guess 0 is a PO. No.
No, what do you like? Why is it? Why
No,
is
0 is
it
gonna be a
critical?
max or a min. I'm gonna guess he's
No,
gonna
because
do
it's-
like this. You see that? Something of that nature.
Yeah, but they.
She doesn't understand how
But
a
how is
vol
that a
and a
critical
critical
number for
number
the
are
second
the same
derivative?
thing.
What you talking about?
Like a vol and a how
Aren't-
is a vol a critical number?
No, aren't critical numbers in the second derivative?
Have to be POIs, not necessarily.
Thank you.
No, not
could be vol.
necessarily.
No,
Yeah, they
that's
could be
right.
VOS. Yep. Okay, so how many test intervals do we have?
3.
4.
I don't want to
Okay.
have 4.
All right, they are from, and they're nice numbers actually. They're from negative infinity to where?
Negative 2.
Negative 2. Negative 2 to
0.
0.
2.
0 to 2. 2 to infinity. Cool. Test point.
Negative 3. Negative 1. 1. 3.
Nice. Okay, now my first derivative,
Beautiful.
I'm gonna go my second derivative, and then I'm gonna go conclusion.
1, 2.
And we're gonna figure out what he looks like. Okay, first derivative. Where is my first derivative? That guy. First derivative is negative 16x over a whole big junk squared.
Yeah.
But it's gonna be positive.
Because, and when we have that whole big junk squared, you guys understand that that's just gonna be a positive number.
Yeah.
So really all we have to do is look at negative 16 times negative 3, negative 16 times negative 1, negative 16 times positive 1, negative 16 times positive 3. He is positive, positive, negative, negative. So he is
Increasing.
increasing,
Increasing.
increasing, decreasing, decreasing. Yeah?
So cool.
Nice.
Okay.
Okay, now, the second derivative, guess what? He is the same way because
Wait.
Each one
Wait.
flips.
So
this guy, hold up, everybody watch real quick. This guy goes away because he's positive no matter what, right? We're divided by positive, so it doesn't matter. Now,
And those
technically, this guy is the same as this guy, right? We just took the 16 out and divided and threw him in the trash can.
Sure.
So can we get away with just doing this one?
Sure.
Sure.
Can we get away with just doing this one?
Sure.
Sure.
Sure. 3x squared plus 4 and x squared minus 4? Okay. So,
Wait, even if we're just
3x squared plus 4 and x squared minus 4.
So
That's my second derivative broken completely down,
how?
right?
Yeah.
It's just factored.
I know, but we took away all the zero things.
No, we didn't. We took away all the what?
All of those things that cancel out with 0. We took away the 16. We took away.
But we divided everything by 16, so it's just going to be a reduced number. It's not going to change the plus minus thing.
Okay.
So it's just going to take him from being 200 now down to 100 or whatever. It's not going to change the positive negative of him. Does that make sense?
Yeah.
So that's how we get away with doing that. We can use the after we've divided by 16 because it's not going to change the fact that he's plus minus. So now I have to plug in -3. Okay. Wonderful. Guess what? This guy right here, check him out. If you take a number and you square it and multiply it by 3 and then add 4 to it, it's always going to be positive. So I only have to look at x squared minus 4. Yeah? So if I have -3 and I do -3 squared minus 4.
Positive.
Positive. Right? Because it's 9 minus 4. -1 minus 4. -1 squared minus 4
Negative.
is a -3, so it's negative. +1 squared minus 4.
Negative.
Negative.
Positive.
+3 squared minus 4.
Positive.
Positive. Do you guys see how we took those shortcuts?
Oh.
Yeah?
Yeah, now I'm with you. It took a second.
Nah. Okay, so what's the conclusion?
Up, down, down.
Concave up? Concave down?
Up.
Concave down? Concave up. Okay, so let's talk maxes and mins. Do we have any maxes and mins?
Why?
If we look at our increasing, decreasing, this is where we look at to find our maxes and mins.
Yeah, we have one.
We have a max.
Right here, we're gonna have something right here, and he's increasing and then he's decreasing, which means he is a maximum. So I have a maximum at 0 right here. This is a high point, so he's doing one of these, just like I thought maybe he was.
So there's
Yeah?
no min.
Okay,
No mins.
and no mins. Okay.
We like no min.
Now, where he changes concavity is where there's POIs, except he
Wait,
changes concavity right here. So is this a POI?
No, but don't we need to find the.
No, because it's a vol.
We need to find
Oh,
the
yeah, sure. There's a max at 0, comma,
something.
what?
Something.
I don't
Wait,
even know
wait,
what
don't you
the
plug it back
original
into
There,
the
we already have it as a dot on our graph though,
Negative
right?
2.
Because it's the y-intercept, so we've already plugged it in. 0, comma, -2. No mins. Okay, POIs. Where he changes concavity is a POI except for if he is a
They're Vos.
vase. Guess what? These both are vase, so there's no thing there. Okay? So we don't have any
Oh, yeah.
POIs at all.
Yeah.
Okay? So what's the graph look like?
Just
That.
parabola down.
He is concave up.
So no POI?
We-
Is that what we said?
He's concave up and increasing and concave up. Now it's important to note that he is not crossing this line because we don't have any x-intercepts, true? So he's got to look like probably this. Is that increasing concave up?
Yeah.
Yes. Is this one decreasing concave up?
Yeah.
Yep. That's what he looks like. He looks like a little frowny face guy with sad eyes.
Oh, I see it.
You see
I
it?
do see it. It looks like a cartoon.
Oh,
And a little hairy mustache.
No.
And
no
some,
mustache.
No,
some
no
tears,
mustache.
too.
And some tears.
Yeah. The tears because of cow.
Yes.
There we go.
Yes.
Color them
Can we do
blue.
20 on Tuesday?
We're all just if we have
Yep,
school
yep.
tomorrow.
That was good. That was good. We
Really?
might actually, that was pretty good. We might actually skip 20 and 34 and move on to the next section tomorrow. How about that? Not
I
tomorrow.
won't be here tomorrow.
Not tomorrow, because we're not gonna be here tomorrow,
Jay
right?
and I won't be here tomorrow regardless.
Oh, right.
Mhm.
Yeah. Are you both going to the same
What?
place?
No, we're staying at home.
We are staying at home.
Oh yeah, you're zooming.
We
But
are
you're both.
Zooming.
It's for the same place, though, right?
Yeah.
Stupid.
But
Well-
different things. So
Different things, same thing.
All right. So that was good. Let's just plan on that, and we will reconvene on whatever day we have next and call it a day. Okay. All right. Goodbye.